So welcome to 2024. This is question B3. It's a axonometric projection question. The image on the right shows the V-sphere spherical puzzle game. Okay, the game includes a stand and a spherical puzzle. Figure B3 shows the incomplete trimetric projection using axonometric axis method of a similar puzzle. So we've got our incomplete one here. The plan and end view are shown in their required positions. A pictorial view of the game is also shown. So here's our pictorial view. That's essentially what we're aiming to produce. Draw the axonometric axis X, Y, and Z and a scaling triangle. So this portion here to begin with. All right. So I'm going to start here in the middle of the page, and there, and I'm going to have my vertical element for my y-axis. All right, and let's measure out my 110 degrees then. Off of that, I'll go up a little bit. 110 degrees. 110 degrees. So that's my position of the x-axis. All right, and then to find the z-axis, we need to measure out 50 this way. So we'll just project that down. So we're going to measure out 65 one way, 65, and 50 the other way. So let's go 50. All right, so that's going to be my point C. Draw the base there, and we've marked off our 50 there, so that's point B. All right, so we've got our x-axis, our z-axis, our y-axis, and I'll extend that up a little bit further. And we've got C, B, and now we need to find the other two sides of the scaling. So they're going to be at 90 degrees. They're going to be at 90 degrees to our axis. Double check that that's at 90 degrees as well to my x-axis. Get myself in order here. Yeah, bang on there. Right, so that is my scaling triangle. There's my y-axis, and there's A. All right, now we want to, part A, complete it. Draw the plan and end view orientated as shown. So let's find my plan view to begin with. Let's project down. Any distance there, and that'll fit on fine. Go to about here. Get my compass, bisect this distance. And draw my semicircle. Here's going to be an edge view of our vertical planes, and we're looking down on top of our horizontal plane. So that's positioned for my plan view, and then out here for my end view. Right, and slide this out. Alright, we'll do the same here. Bisect the angle, or bisect the distance. And draw my semicircle. So setting up these axonometric projection questions can be a bit repetitive. Okay, so it's an easy way of pick up marks. The only thing that might change is your angle for your trimetric or dimetric or isometric. So we got our positions now of our vertical plane, horizontal plane there. Now we want to draw, they said plan, then end view. So I like to draw the plan first because they said plan first. All right, so we've got measurements here. I've got 70. Halfway along there, we're going to have that edge, which is 35. And that's going to be 100 long. So 100, about there. All right. Okay. And okay, so we've got the outline of the prism, the triangular prism. So this starting part is pretty simple. Once you know the setup, we're just following the measurements they've given us. So our circles here, we've got a radius 25, okay, and this circle here represents the sphere, okay, so our sphere is radius 35, and we can see that anyway from that distance. So I do need to find halfway along that. So that's going to be 50. Okay, set my compass to a distance of 25. So there's my cylinder. Okay, but I have to show this hidden detail. So dash line. All right, and now my radius 35. And that's my sphere, and that'll be heavy. Okay, and finish it off then with my heavy line, hidden detail line in between. So okay, so there's my plan view completed, and now I need to draw my elevation. So elevation, end elevation, what they have in common is the depth there, or the width there, whichever you want to call it. So that's 70, will be 70 there. Okay, the distance here will be the same as my cylinder, radius 25, so 50 the whole way across. So let's start marking off those distances. We've got 70. All right, and to the center there, that'll be 35. All right, and we got some heights actually. So I got 75, 55, so 75. That's 55. Just center of the circle, yeah. Okay, and we'll start. Our center line. Height then is 75, so let's send that across. Okay. So let's draw my triangle. It is 75, yeah, 70. Triangular prism. Okay, and our radius 35 then for our sphere, and that's the center of our sphere. Right, we can draw that up here. Okay, and then finally we have our cylinder, which is radius 25, so 50 across. So all right. Now, that is complete the plan and elevation as shown. So, or end elevation as shown. Yeah, I've got everything there. So now we want to complete the trimetric projection of the stand. Okay, so we'll start with each element and we'll work our way up. So we'll start with the triangular prism. So we want to get this outline. This is what we're trying to get. So I can project up vertically there. Project up. Project up. Okay, and let's project back then along. So we're just matching up points, pretty straightforward and self-explanatory, I should say. And the last part. Okay, so now we're not going to draw the full thing because, as you can see, right, that line runs across the middle there, so we're not going to have the full thing. We need to find that surface. So that surface is on our cylinder. Okay, so what we're going to have to do is find points on the cylinder and find the corresponding points over here on the end view for the cylinder. So we'll do that using generators. Now there are already 1, 2, 3, 4 points already found first. So we'll find those corresponding points. So There's my center. Okay, so now we're going to split this up 60-30 using this angle. So yeah, I'm going to have to use kind of a sliding set squares on this. So set that against my edge. Now I'll go 60-30. So splitting up 60-30, using that as my guide. The edge of the triangular prism is my guide. That just means that I get kind of cleaner lines or easier lines to work with. So let's number these off. So we'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, so now I need to find those corresponding points over here in the elevation. So I'm looking in this direction. Okay, so right down the middle, I'll actually see 1, 7. So all my other measurements are going to be based off that. So let's let's find those distances. I'll just mark them up. So these will be the same distance. That will also be the same distance. And then 5 and 9, 6 and, just to mark, show them, they'll actually be the same distance as the ones I just marked because they're symmetrical. Right, so distance from our center out 2 will be the same as 12. So that's 2 and 12, and it's also 5 and it's also 6 and 8. So we're going 2, 6, and 12, 8. And the distance from 3 to 3 there, it will be the same to 11 and 5 and 9. So mark that off. Mark that off. And we've got 3, 5. And we've got 11, 9. And outside we've got 4 and 10. Okay, so that's finding points all the way around that surface there. Now, let's find those points up here before we were talking about the base or where they intersect. So it's just a matter of projection. So point 1, project it up. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So I know this is getting kind of busy here, but if you use indexing like I've done, it'll be relatively easy to follow. So let's start with 1. 1 has already been brought back, and here it is. Okay, 7 is already, so that's 7. They're on the same level. Okay, so now let's go to my outermost points, 4 and 10. I like to just because it just shows me where I'm contained within. So 4 and 10. Yeah, it's 10. And 4. It's there. 4. So I got 1, 4, 10, and 7 found. Okay, let's continue on with the rest. So we've got 5 and 3. Here's 3 coming up. And I've got 5 coming up. I've got 6 and 2. So there's 2. And 6. 12 and 8, so 12. Just checking your lines, it's 12. And 8. This is 8. Outside it, that's 8. And then finally we got 9 and 11. So 9 and 11. Okay, so now I've got my circular top there of the cylinder. And join up those. So that's appearing as an ellipse. So looking at the pointer, going to not at the point of the pencil, that will give you a nice gradual curve. All right. So let's finish this off. Okay, so I'm just going to join up the top edge here of my triangular prism now that I've found point 1 and point 7. Okay, if we go back along here, I've got all these different points. So we need to find, use a color here, I might be able to see it better. So we found all these points all the way around it. Okay, we need to find these points now. So what we're going to have to do is we're going to have to create generators that contain those points. Okay, now we've got the position of all those generators already, so we just have to draw them in plan, or sorry, in the elevation. That'll find us maybe a point. We'll already have the corresponding point in plan, and we just join them up to find that curve. So let me just first of all draw these generators down. So that's 9 and 11. That's 12 and 8. I don't think we're going to need the ones at the back. Right, so we've got these points here. Okay. These have already been projected up, so we just need to project back from the end elevation down. So that's for 12 and 8. So I go to 8 here. Point. I go to 12. That's a point. And we've got next one down is for 9 and 11. 9 and 11. And finally we've got the one for 10 already there. Bring it down. There's 10. Okay, so those are my points. And finish that off. Yeah. Go from 8 down. Be straight down. And now we're going to have our freehand curve. All right, and at the back then we're going to have this line coming down. Represent that. Okay, so a bit of work in that, but nothing too complex. It's essentially working with generators. All right, and that completes part C. And then the sphere is presented above the stand as shown. So here's our sphere floating above the stand. Complete the trimetric projection of the sphere. So a sphere does not change its radius, or a sphere projects as a circle in all orthographic views or in all views, and the radius isn't going to change between whether it's 3D or in the 2D views. So we're still going to have a radius 35. We just need to find the center of that. So we're going to draw that up and match it. So I've got my center. I'm going to project that vertically up. Find the center in elevation. And project that back. So here's my center coming up. Yeah, there's my center. My radius is 35. And I can draw that sphere in place. Okay, so that is that question completed. So it brings us to the end of section B in the 2024 paper. That wasn't too bad a question, really. Okay, bit of finicky bits here with the intersecting solids, but use generators and we can solve that.